The next exponent rule I wanted to review is that anything to the 0 power is always equal to 1. And this rule is often one that's a little bit stranger, so I wanted to dive into, well, why is that the case? There's a lot of different ways that you can explain this or justify this, but my favorite way is by thinking about what exponentiation really means. So again, let's start off with like 5 cubed, 5 squared, and think about what those things mean. And what I'll do is I'll kind of think about a table. So in the table, let's just say I was thinking about a particular exponent to which I'll just call x. And then in the right column, I'll think about, well, what does 5 raised to that x power look like? And kind of set it up as a series of patterns where, let's just say I was looking at, 3 or 2 or 1 or 4. Well, if I was thinking of 5 squared, 5 to the second power, that would be, again, that would mean, well, 5 times 5. Put a little more space here for reasons. 5 times 5. And if I was thinking about 5 to the third power, that would mean, well, 5 times 5 times 5, or 5 cubed. And if you've ever wondered, well, why are these things called squaring and cubing? It's actually because it relates back to the area formula for a square. If you think about a square, which was 5 by 5, the area of such a square would be, oops, I'm drawing something, but you can't see it. If you're thinking about a square, right, which was 5 by 5, the area of a square would be, well, 25 square units. And the reason why we call them square units, this is one of those other things that I was like, I didn't really understand, why do I call it, square feet or square centimeters? Because it would literally create 25 squares or, square yards, whatever, if it was 5 by 5. And really notice that 5 squared gives me that area, which is just 5 times 5. So that's kind of the reasoning. It's a very geometric reason why we call it squaring. And the same thing goes for cubing. If I was to look at a cube, like imagine a sugar cube or something, which was like, I don't know, 5 by 5 by 5 in each parameter, because right, that's the property of a cube, is that all sides are equivalent. Well, the volume of such a cube in cubic units, again, I could kind of imagine breaking these cubes into little bits of 5. The total number of cubic units in there, if I were to break those into little cubes, would be 125 5 to the third power, or 5 cubed units. Now there's no like shorthanded name for 5 to the fourth power, like that, at least with respect to geometry, because how do you do a 4-dimensional shape under the same idea? But of course the meaning is the same. 5 to the fourth would just be, well, 4 5s multiplied together. And if we were thinking about 5 to the first power, that's just a single 5, so kind of makes sense that that would just be 5. But what if I was doing 5 to the 0 power? What would that be? And if you were kind of thinking about this pattern, you might say, well, why is that not just 0? Because if I don't have any 5s, shouldn't that be 0? And you're not entirely wrong if you think that, because that does make some sense. But really the reason why it's always equal to 1, as I was just saying, is because what exponentiation means. Exponentiation is always a chain of multiplication. And if I was thinking about a pattern and thinking about, well, where would it start? If I did not have any 5s, starting at 0 doesn't make any sense. Because if I were to start at 0, think about this chain starting at 0. Basically, well, then if I took 0 and multiplied by 1 5, that wouldn't make 5, it would make 0. And same with 0 times 5 times 5, none of those would make any sense. So 5 to the 0 power must be 1, because 1 is what's often referred to as the multiplicative identity. It's like the number which is the start of all multiplication chains. You cannot start it with 0, but like when it comes to adding, nothing means 0. If I have nothing, that's just 0. But when it comes to multiplying, I mean, technically 0 still means nothing, but in terms of having no factors, you always have to start with 1 because it's the beginning of a multiplicative chain. And if I think about this pattern now going forward, it makes a little bit more sense, because if I don't have any 5s, that starts with 1. Each chain of multiplication could start with 1, and it fits the pattern. So what 0 5s means in a chain of exponentiation is always 1. So like looking at the sheet over here, it looks like we don't have any examples to the first power, to the 0 power, but you can just remember that anything to the 0 power is 1. And a common tricky one, let's say for example I gave you 3x to the 0 power. all that being said, remember that when you have an exponent upon something, the exponent only applies to what it's directly next to unless it's in parentheses. So basically x to the 0, anything to the 0 is always 1 because it just means I have none of those factors, which would equate to be 1. So really what this would leave me with is 3 times 1, which is equal to 3. It wouldn't just be 1 because 3 is not raised to the 0 power, only x is. Now, if I were to write it like this instead, 3x to the 0 power, then yes, that would be equal to 1 because the whole thing is raised to 0 power, and anything to the 0 power always is 1. Again, for that same reason, because if I have nothing, when I'm talking about multiplication, we always start at 1.